Hey everybody, welcome. Like we said, we're here to talk about observability in the loop today. So if you're here, you're in the right place. If you're not, it's too late. You're stuck with me. Uh, so here we go. I'm gonna apologize in advance. Usually, I'm a very pacey speaker, so it's gonna look like I'm vibrating through the ceiling here. Uh, Generally wander around, and also this is the first time I've talked to people since the before times, right? So usually I'm just talking into a computer. I'm like, that's fine. But now there's people, and this is tripping me out. But thanks for coming. Like we said, my name's Tyler Auerbeck. I've been a bunch of places. Presently, more recently, I'm a principal engineer at Equinix. Focus a lot on running kube clusters and focusing on developer productivity. And as you can tell, I'm clearly super professional. I've not been bothered to ever get a headshot, and I don't know that I ever will. So what you get is me in the unicorn, inflatable, and a wizard hat. Apologize. But like I said, so I'm working on kube clusters. I focus on developer productivity and platforms, helping our teams bring that sweet network to all of our users. Right. In my free time, I am equally as nerdy. I focus on the same things. I play around with Kubernetes, the Grafana stack, which we'll talk a little bit about here, Flatcar. So I feel very passionately about all these things, and I want I want that passion to go to other people. So that's why we're here, right? If you care to chat about any of these things after the talk, you can find me. That's the same username basically on every Slack ever, but also on Blue Sky, on GitHub. If you want to yell at me after this talk, forget about that part. So, with all that said, what we're here to talk about today, like any rational adult, I submitted a conference talk because I had some real strong feelings and I wanted to talk to people about it. So welcome to my personal therapy session. You see, here in the era of SRE and DevOps and platform engineering or whatever else we're calling ourselves these days, I was made a promise that we would have these fantastical cross-functional teams, and I'm not seeing it. And it hurts my feelings, right? I was made this promise that we would establish these teams, and those teams would ship the code, all the code. That code would be testable. That code would be observable. It would get into production, and chef's kiss, it would be running perfectly. I haven't seen it. It's still this magical land off in the distance, right? But instead, what I found is I was promised that there'd be no more fences to kick our problems over, and instead, what I found myself is I'm surrounded by fences, and everyone keeps throwing their problems to me, right? I run a bunch of platforms, so when something goes wrong, they're like, "No, it couldn't possibly be me. What's wrong with your platform? Solve it for me," right? And as a systems person, that's the feeling I get. And I just went on this diatribe about cross-functional teams. So the fact that I'm calling myself a systems person kind of goes against all that. Forgive me. I just recently found out I'm the old cranky guy on the team. So old habits, right? And also a bit of Michael Jackson man in the mirror thing. Sometimes the problem is me looking in the mirror. I'm like, you did this to yourself. Maybe you should stop doing that. But all I can say is I need it to stop. We all need it to stop. If we're going to be successful, we're going to ship all successful production applications. We need to figure out what's stopping teams from getting this magical cross-functional future that we've all been promised, right? So that's what my problem is, right? Because the way that I see things get shipped, the way that I see things make their way to production, right, is in 3 stages. I call it stage 1, the blip, light bulb. We've got this idea, good or bad, an idea has been had, and cool, time to get this thing into production. I've got a problem to solve, right? And then stage 2, ship. My idea has become load-bearing. Someone, at least one other person, maybe, has thought that this was also a good idea, and we got to get it out there to solve that problem. Get in the car, nerds. We're going to production, right? And then we get to stage 3, which is my favorite stage because I get to say all the curse words. I won't say it for the recording, but imagine, right? We started off trying to solve a problem, and now we've become the problem. And it's all on fire. And we don't know why, because we never spent the time to make sure that the thing we're shipping, we knew how to measure whether that was going to be successful. We just we built it, and we said, works on my machine, couldn't possibly break anywhere else. And I think we all know it breaks everywhere else, right? There's always going to be something missing. And whose problem is that? When something stops running, whose problem is that? It's, of course, the app team, right? You build it, you ship it, you operate it. It's on the stickers. The stickers would not lie to us. The stickers lie. But the problem really is that we've gotten really good at building applications. I wouldn't even say building applications. We've gotten really good at writing code, right? Because we got all those tools at our disposal. We can do all these things locally on our machine and make sure they work. And we can make sure, I build it, it runs, cool. And all those tools are available to us locally. But the thing we're missing is that we don't know what happens next, because we don't have the components we need to be able to say that, okay, once the thing starts running, it's still doing what we expect it to. We can write tests, right? We can write those tests, but we can, that only tells us so much. We also want to see it run. And then we want to see that after it's running, cool, I can go to these systems and make sure that it's behaving as I would expect, because we can observe it. So really what we need to figure out is what that user experience, developer experience needs we need to flex those muscles. We need to provide that UX, DX to be able to do that, right? So why is it so hard? You close your eyes, you put your hand on the desk, like, why are we doing this? Why can't we fix this problem? Because it feels like we all know it's a problem, but it keeps happening, and we don't want that, right? So why does it always get left behind? I like to break this down into two parts. This first part is the concepts, and then we'll talk about the second part, which is more of a technical implementation challenge, right? In theory, it's hard because when you're coming up with an idea, there's clearly an immediate problem you're trying to solve. So we can solve that problem. But how do you know to measure how it's being successful, right? You might have some sort of idea, but the way that I see this tend to happen is cool, I solved a problem. I run the application, the problem is solved. I guess we'll put it out there. And then when it breaks, the fire that we were all talking about, that smoke starts catching. Then I'll go start measuring something to say cool, don't let that happen again, right? And the problem there is that's very reactive. And you're not going that means you're just going to let production incidents keep happening and then resolve them. And then cool, they won't happen again. But cool, just keep death by 1,000 paper cuts, essentially. And sure, that's a decision that I've also been guilty of. But it's very, like I said, it's something hurts, make it stop hurting. And this is where I get to some more, welcome to stage 2 of the therapy session, my more big feelings, right, about SLOs. If you're building something, you should at least know how you expect your users to interact with it. It's not going to be perfect, but there should be something that says, hey, my user is going to, I know that I'm going to have a user that looks like this. They are going to expect A, B, and C. How do I make sure that A, B, and C are a green light and not red light? So again, it doesn't have to be perfect, and it doesn't have to be robust. You just want it to be something. And what I see a lot of is that we'll get to these points where, yes, we've thought about it at least, and we say cool, to do, right? Everyone says that the path to the bad place is littered with good intentions, right? And I say no, it's littered with to-dos. And you say, isn't that good intentions? And I'll say, it's an intention for sure. It's one of the most frustrating things, because instead of writing a to-do, all you have to do is stub in some code. Even if it's doing nothing, stub in some code, because what I've found is the best way to solve a to-do is to write bad code. Because there's no easier way to get an engineer to go fix something than to annoy them into the dirt. Because if it's going to sit there and it's going to pester you, and it's going to either fill up your logs, or it's going to like have some really annoying box that pops up, or it's not going to do the thing you want, that's bad developer experience, because it's like, why is it doing that? Make it stop. And then if you, for some reason, let that get out in front of users, you're going to say, the user's going to be like, what? Why is this happening? Why do I have this weird, like, flashing yellow light off to the side, right? One, that is your forcing function. What I've found is that if you can't give yourself a forcing function to go solve a problem, nothing to force you to go solve the problem. If you let it like hide in the comments, it will not get solved. But if you make it annoying, you can, one, it'll annoy your engineers. They'll go build the thing. Two, your product folks will say like, that is horrible. Go fix that. And then you can prioritize that. Because in this day and age, it's not just like an engineering problem. You also need to prioritize the engineering problems against your product problems, which are not always aligned, right? Oh no. There we go. So do yourself a favor. Get on your nerves. Become everyone that uses your application's problem, because that is how you're going to at least get something to happen. And what, like, the reason I call this out is like, just do something, because sometimes if you just do something, you'll find out that minimum of, you may have thought it was this big chunk of work, but at the end of the day, you might find out that just that little piece was enough. And you're like, oh, I didn't need to do this wildly complex, robust solution. I just needed to do this one line, right? And that's good too, because again, starting from something you can iterate on, or you can find out that that's perfect and you can leave it alone, move on to greater things. You might find out that eventually, like, whenever we invent time travel, that'll be the thing that lets you like go back in time and like gives past you a high five, right? So that's the theory. That's why I think it's hard in theory to do that thing, right? The in practice part, which is like where I'm gonna like make frowny faces a lot. So apologies in advance. But the hard part in practice is that even if we're doing everything out, we're out here killing it, right? Doing a great job. It's brutal to actually have the components you need to do the things. Because remember, like, shipping telemetry is not observability. Have it like, cool, I'm emitting metrics, I'm emitting traces, I got logs. That's not like the observability dream. It gives you information that you can work from, but that's not like the end of your observability. If you're under the assumption that's the end of the observability, vacation that you want to go on, the dream that you want to reach, got some bad news, because that's the beginning. Like, you have something and it's telling you that's your information, right? Or that's the data that you're working with. We want to get to like information and knowledge, right? We want to be able to take all of that data that's flowing in and make something useful out of it. But it's hard, right? Because I don't know how many of you work kind of in this area, but the problem is that all those systems that help you collect that data tend to be like software as a service things, not things that are super easy for you to put on your, like, to provide to your developers. Because like there's I consider there to be like a 2 or 3 type of problems here. One is I can't actually run this locally a lot of the time. I won't say that for everything. Like, I'm going to talk about a specific stack. Maybe there are a few more stacks out there that also don't make it super hard for you to do the thing. But a lot of this is software as a service. Problem one, you might not always be connected to the internet. So when you're doing your observability development, you're like, cool, I can take it to here, but like, I gotta go find some Wi-Fi before I can do this next part. I've been on planes, trains, automobiles. I've traveled back to visit my family, which has horrible internet connection. And it's hard. You're just sitting there. It's spinning. It's not connecting. You're like, cool, I'm going to go do another thing. Because if like engineers are, we see shiny things, we go off and do something else. So if we're like, I'm going to go wait, then you find a new adventure to go on and you forget to come back, right? Problem two is, even when you do have connectivity, admins don't love passing around credentials to very sensitive systems that hold telemetry for your entire organization. And if you are passing around credentials to all of your developers, I'm sad. and you should stop it and find a better way. Yeah, so we don't love doing that. So please don't. Like I want to say like I'll come find you, but like that's no. Like I'll just look at you disapprovingly, and you should feel sad. And I mean, seriously, none of these things have a way for you to develop locally. It's brutal. And what we want to do is we want that promised future of like we can spin all this stuff up locally, we can develop, we can ship the feature. And as all like that's when I say shipping the feature, that's shipping your application components, that's shipping the observability components. So yes, initially you'll be emitting all this telemetry data. So you'll be emitting it is the first part. But you also want to be able to ship your dashboards, ship your alerts, things like that. And if you can't do that locally, or if you aren't easily able to pull that into your loop, you're missing a huge component, because now you have to wait for something to get into production, and then you have this second loop where you go off to the system where you need to build it in. We want one loop, right? We want that nice little infinity looking symbol. We don't want like this infinity symbol and then just like this tree that grows off the side. Because everyone sees that fork in the road, you're like, I'm going to stay here where it's safe. Thanks. We'll get to you later, right? And this is probably where I need like flashing red light. I am not sponsored by Grafana. I'm going to talk a lot about Grafana today. Grafana is not the only solution. This is an example of what's like the art of the possible, right? Like you could probably do this with a number of other systems. I know this full stack to work, and I want to give you all a goodie, like the goodie bag you're going to leave this talk with today. I want you to have like something that's functional, right? So feel free, plug in all the things that you work with, but Grafana works just fine for me. They don't pay me. I tend to pay them. But I've been using them since they were since it was just Grafana. But the beautiful thing is they've come a long way. Now you got Grafana to help you visualize things, right? But now we've also got Loki to get you some logs. We've got Tempo where you can get your traces. One thing they're horrible at apparently is acronyms. LGTM, right? Looks good to me. Loki, Grafana, Tempo, Prometheus? Where'd the M come from? So it's Mimir, which is like it's based off the Cortex. It's the Cortex project, right? You'll hear me saying like, yeah, we're using the LGTM stack. I don't spin up, like we're all, again, we want to keep it light because we're running it on our local machines. So we just use Prometheus. It's a Prometheus compatible component. It does the same thing. So we'll use Prometheus here. We won't spin up the whole thing. So yeah, we've got the LGTM. We've got all the tools we need to do the thing. The thing I love is that all these sources are available. One, I can go contribute to it, right? We can argue about what license is happening. No, not here, out there. We'll go talk about licenses somewhere else. But it's open. I can go look at the code. I can go contribute to the code. I can pull that code down locally and run the thing. I can tie it into my whole system. And that's what I love about it, right? And that's cool. So cool, we can give all these things and we can give it to our developers and they can run it locally. The hard thing is we have to give all of our developers these things and they have to run them locally. Which to me, as a systems person again, like that's cool. I'm gonna spin up all these systems. I do this on a daily basis. But say you've got a new person joining the team, right? I don't want it to take them a week to get up and running. I want them to just like, hey, here's your computer, press enter. Your stack's up. Here's the applications that you're developing, and here's the systems that they need to be able to develop. If we expect them to also know how to spin up all these things, especially our junior engineers that are coming right out of school, right? It's going to take them in the time frame of multiple days, a week or so, to get up and running. And that's just to get the thing running on their computer, let alone starting to have them be able to produce value off of these things. That's the opposite of what we're looking for, right? My solution to putting observability in the loop is not to give people more things to run. I want them to still just like hit enter, get to it, right? So I bring you to the bubble gum or the glue of our situation, right? So we've got our application code. Now we've got the systems that will enable us to do observability development. the bubble gum to tie them together, to spin it all up together, is Devcontainers. It's an application and a spec that allows us to pull all this together. We're able to specify exactly what the environment should look like. And when I say environment, I mean all of it, right? Like, so I'm saying, hey, this is the container that's going to spin up, and it's going to have my application code, and it's going to do the thing. But also, it's going to, I can say, like, in my VS Code, I like these plugins, and it's going to add those plugins for us. And I know some of you are like, VS Code, gross. Send me back to my terminal. It works in VI, right? It works in NetBeans. It even works in Emacs for you sickos out there, right? But it works against all these systems. It has plugins for all these systems. So if you've got your super special customized Emacs or VI configs, you can plug them right in. It'll work off to the races, right? The really cool thing that I like is that it's not just like you can build this dev container spec, and it's not just it like solves your local problem, but then in addition, it solves everyone else's problem too. I can do my development, and then when I put it in CI, I don't need to say like, cool, spin up X, Y, and Z, and then run my application, build my application, do the thing. Now that I've got a dev container spec, like I can have one line in CI that says like dev container up, and it'll instantiate all these things for me, right? Which is an added benefit. The thing that I've always tried to do is I say like, cool, you do whatever you want in your CI. The thing that prevents you from getting production is passing my CI, right? And then as you start to, as these concepts start to percolate between teams, if everyone's following some kind of standard, cool. Now all that you need to do to make sure you can get into production is like, you've got your dev container. Cool, as part of my CI, I spin up your dev container, and I see that it does the things that I expect. And then I let you through. No more like, all right, well, this is how we do it over here. Let me go build a separate CI pipeline that like makes sure that your stuff comes up and does the right thing. Now everyone says like, how do we test our CI? Dev container up, and then test run. Amazing. So that's the gum that pulls it all together. But you can, by default, that only allows you to like spin up your dev container, right? Okay, how do we plug in that observability stack that we were talking about? How do we also pull that in? Well, instead of just having like a vanilla Docker file or a custom Docker file of your own, and then trying to shove all these other components in your Docker file, that causes problems. Not the most being that like the value that you're trying to bring to your company is not figuring out dependency nightmares, right? Because that's not how it's going to be in production. In production, all these things are going to be independent systems. So as part of your CI or part of your local development, why would you want to try to turn them into one thing? Let them be their own systems. The benefit there being that there's already a system that allows you to do this. I'm sure a majority of us have seen projects that have a Docker Compose file. So we get to lean back on our old friend Docker. And I get it. I'm in Red Hat territory today. I believe, 99% sure this also works with Podman. I know it would work with Podman just because like there's a thing that like just like, hey, just pretend Podman's Docker. It's gonna be fine. I will go double check this when I get out of this talk just to be sure, but it should work. So it's not just Docker, like scrub out the whale, put the pod in there. It's gonna be fine. But we have Compose, right? We've got this Compose spec that what I really like about Compose is you can define your dependencies between all these things. You can define, as expected, you can define what image, what arguments it's going to run. Hey, I want it to be on this network. Maybe they need to be on separate networks, or they're on the same network to make sure they can talk to each other. The volumes and any files that you need to shove into your applications, you can make sure there. I really like that you can say like, this thing can't come up until these three are up. And actually, I need this thing to initialize some data first, so this one comes up first, and then these other ones can come up. But it allows you to orchestrate all of these containers coming up and being in the right shape that you would expect. Sorry, this keeps going off. So it allows you to have all these things come up as you would expect here, and we'd be in good shape. the beautiful thing is now that we've built our initial loop, right? We have got all these things coming together, and now we need to get off and start building our observability. The last thing I'll say, again, this is my therapy session, right? I'm going to tell you about the things that hurt me. Some applications, they've got this beautiful hot reload capability. I build in Go. It does not. So my life, I've only got so much time left on this beautiful earth of ours, right? I do not want to spend it start, stop, sitting there wondering why my features the code that I just wrote, why isn't it working? Oh, it's because it's running the old version of the code. Stop, start it, rebuild, start it again. We don't want that. We want it to just work, right? There is a feature, Docker Watch was just introduced as part of the Compose spec. It's not quite tuned in and working with Devcontainers yet. I see that the issue is out there. People are working on it. It will be beautiful. Not there yet. So watch this space. It's coming. But today I needed to find a thing that worked with Go, right? So I'll introduce you to Air. Not that Air. But it is an application called Air. It basically allows you to, it's another configuration file. I don't love taping in all of these additional tools, but in this case, like, it stops me from doing the start, stop dance. So here we are. But it allows us to say, hey, this is how you should, when starting up, this is how you should build the application. These are the files that you watch or don't watch, which is especially useful in mono repo, like big mono repos. But as things change, it will reload your application, and you get that same functionality that you do with other languages. So I think we can all see the benefit of that, right? Round and round the loop. That now we have, instead of just having a loop and we're not moving around it, now we have something that keeps us moving around the loop. As our files are changing, it keeps us going. So round and round the loop we go. Where do we stop? Right here, because I'm tired of talking, and I very much would rather just show you all how this works. So we'll see if we can get the mic in here. So I'm going to switch over to the demo here. F1, we're going to do that. So the thing we do here is, as you can see, I've already got a bunch of this already running. Why? Easy bake oven style. I'm not going to let the demo gods come get me. But the way that this would work is I load up my code. I use VS Code. If you're using the CLI, you just dev container up. It's a CLI. See down here a very tiny box that says, hey, you got a dev container configuration. You wanna do the thing? We're gonna click yes. So imagine I click the button, close this one up, and ta-da, it's ready. It's already baked, right? So the thing you can see down here in the corner is dev container go. So we can see that it's already spun this up in a container. You can tell that I'm in a container because if I try to say Docker PS, just like I just did, it says, hey man, you don't have Docker. This is a completely different environment. So we can see that the first thing we have here is a devcontainer.json. That's where we can say that, here's what we want to do. As I mentioned, I'm not just using the image. I've got a Docker compose. The service name that it should look for to spin up that application is part of that compose. And hey, shove all this in this workspace folder. As I mentioned, I didn't go all in and describe my whole VS Code, but you can say hey, get the Go extension, get Copilot in there. I'm terrible at spelling, so get me a spell checker, right? And it pulls it all in there. More interesting, I can say after my environment's been built, maybe go do these other things. Again, I didn't want to have to I'm fine with just a Go environment, with just the Go image. But I also wanted Air. So I said, hey, give me that base image, but can you do this one extra thing for me? So we have this post create command that says, hey, go get that tool I need. So we can see now, I can say which, I'll make this real big so we can all see. We can say which Air, we can see the Air is now obviously not part of the base Go image, but I put it there. So it's there now. I mentioned a Go file, which I don't think anyone is going to accuse me of this being beautiful at all. But we can see that I've got a very silly application where I've got my dev container, which specifies like how to mount things in, some environment variables. I've got Valkey, which is super insecure. You don't do that. But it brings me up a Valkey so I can store information and things in there. But more importantly, that observability stack we talked about, right? I've got Grafana. I've got some things commented out. I've got Prometheus, all configured to do the thing. Which again, we don't want people to have to know these things, so we make them not have to. Put it all in this compose file. When they click dev container up, you saw all those containers that are running. I've got Grafana. I've got Prometheus. I can prove to you that I've got it because if I come over here and I reload, you see I'm hitting localhost. It worked. We can see that it's already there. And not only that, you can see that if I go into my data sources, look at that. All my data sources, I've already got them rigged up. It's pulling them in, right? And jumping ahead a little bit, if I go here and I explore my metrics, I can see that my metrics are already exposed. I can see that my logs are showing up. So, again, we're emitting telemetry. We've taken our first step of we've collected the telemetry. Now, as I'm doing my development, I can come in here and I can work on my dashboards. You can see that, again, pre-baked. I already built one. It's probably got nothing because I didn't make any API calls yet, but it's there. The benefit there being that, hey, I was working on a feature, it needed a dashboard. So I built a dashboard. If I went and I gave this to any of you, when you spin it up, what do you think happens? The dashboard's there. Now the next person doesn't have to rebuild that dashboard. They know that that's part of the application. And then when I ship it to production, however the CI gets my things into observability land, it just picks them up. It knows where it can go pick them up at, right? So now we're not just shipping our application features, we're shipping observability features. Again, we're not just emitting that telemetry data, we're now building knowledge and things that we want to observe on top of all that. And we're able to see that working. Now I've got a few minutes here, so let's just see if I can make this go. I guess the last thing to talk about is we talked about air. You can see that it's pretty basic. I say, hey, pre-command, because I generate everything off an API spec, as we all should. It says go, before you build this, go generate. The command you want is go build, put it in, build that thing, run it from the temp directory, and then the commands to make it come up is serve. So it's devconf serve, up it comes, right? I want to exclude anything in my dev container file. I want to include just these extensions, so it's not, hey, every file that changes, something's going to happen, right? But I'm able to bring that up, and the way that I then run it is I say air-c, air.toml, and we can see it says air, it's running the thing, and we can see that my echo API comes up. Really cool. And again, being just within this containerized environment, I don't have to worry about like all these tools being on my machine. It's all bundled up. So all that knowledge, all of that stuff bundled up together, we're able to hand that to every single member of our team, and they're able to. I hire someone, they come in the first day, I can high five them, hand them a laptop, and say, run this command, and they have the world in front of them. And that's the world I think we all want to get to. I don't want to have to sit down with every one of my junior engineers and hand around the shoulder. Let me tell you a story. I don't want to be the keeper of the scrolls, right? That's what I've always referred to, like the elder states person of the team is like the keeper of the scrolls. You have the knowledge of, hey, you need to go grab all these things before you can be useful. No more, right? Grab your repo, you can be useful today. So going back here, we'll just wrap up. Hopefully that was useful. I'm going to publish the slides, the code repo, go around, play around with it. As I mentioned, find me in all these places. Come talk to me, come hang out. I love talking about this stuff, so like just send me a message. I will gladly set up time to talk if anyone wants to know more about this stuff. But thank you for coming. Hopefully this is beneficial. I know we speed ran the demo a little bit, but as I mentioned, the code will be out there to play around with. And if you've got any questions, feel free to reach out.